Very excited to have you on our YouTube channel. I'm Eric Hayden. I'm the Warning Coordination Meteorologist for the National Weather Service. I work out of the Newport Morehead City office. That's across far eastern North Carolina. This is our basic winter sky warn, a new class we're doing here. And this is a long version, about 50 minutes. We're going to go over some of the hazards across eastern North Carolina. And by the end, our hope is that you report snow and ice information to us when you get it. If 50 minutes is too long, check out our short version, also right here on our YouTube channel. That is about 10 minutes. So this is our first online class we're doing on YouTube with this. Our hope is that you learn a little bit more about the Weather Service, and by the end, you're an accurate spotter. We do give you the chance to register to become a spotter by the end of this class. This is our agenda. About 10 minutes, we're going to go over the Weather Service, why we need spotters, then about 5 minutes on some of the products that we offer. We'll cover winter weather hazards in our area. That's about 15 minutes in length. Then the core of the class is actually the last third, and that will go over what we want reported, where you can take measurements, and when to report information to us. And at the end, we'll talk about some wrap-up in terms of future classes. The National Weather Service, a lot of offices in the country. The focus with this one, I mentioned I'm out of the Morehead City office. So some of the pictures of our office, some of the things that make us unique, you can see behind the building that what looks to be a soccer ball, that's the Doppler radar, the protection for it. The picture on the right, you can see the radar on top of the tower, but also that dome-shaped building, that's our upper air building. We launch weather balloons here twice a day, 7 a.m. and 7 p.m. depending on the time of year. It could be a little earlier if we're on standard time, but we launch those balloons to measure the atmosphere above us so we have a more accurate picture of what's happening. We are open 24/7, so much like police, fire, and hospitals, we are staffed for emergencies in terms of weather, so there's always somebody here. If you were to visit me on a day shift, Monday to Friday, we may have multiple meteorologists. If you were to visit me on a weekend or an overnight shift, there may only be 2 of us. So it really depends on what's going on, time of day and time of week, but also the weather. If there's a blizzard or Hurricane Matthew or Floyd, there's 15 of us here at the office, so it just depends. The graphic on the lower right is our area of responsibility. The area in yellow is the area that we issue forecasts and warnings for. So we cover eastern North Carolina, as far west as Greenville, Kinston, and Jacksonville. But we also cover out into the waters, whether it's the Pamlico Sound or the Albemarle, and 20 miles out into the ocean itself. And beyond 20, from 20 to 60 miles, that blue shaded area, that's where we issue warnings only for. So about a 2 to 3.5 hour radius across our area. If you're watching us from southeastern North Carolina, you're covered by the Wilmington office. Northeast North Carolina, up by Elizabeth City, you folks are handled by Wakefield. That's near Richmond, Virginia. And the central part of the state is covered by Raleigh. When the weather turns severe, you can count on us. That is the main thing that separates us. We fall under the Department of Commerce and NOAA, and our main mission is to protect life and property. So while we issue a 7-day forecast and we may tell you how to dress for the next day, our main goal are watches, warnings, and advisories. And again, that's to protect the life and property of those that live in our area. We rely on our media partners, broadcast sector, to help us get out that message, but that's kind of a distinguishing factor. The Weather Service is responsible for issuing those warnings and watches, and then we rely on others to help us get that message out. This graphic shows all the offices in the country. Each blue circle, over 100 of them, represents the National Weather Service Forecast Office. So we have a couple in North Carolina. I mentioned Wilmington and Raleigh, and Wakefield's up in Virginia, but they cover part of North Carolina. A couple of the other symbols, a triangle down in southern Florida, the National Hurricane Center. So we do have national centers we work with, but that gives you a good idea how many offices we have across the country. To bring it home a little bit, we talked about the Weather Service and where SKYWARN comes in, and this is the basis for this class. Its goal is to provide the Weather Service with ground truth reports of what is actually happening where you live. Is it as bad as the radar says, or perhaps it's not as bad as what the radar says? And that's where folks that are trained really help us out. You folks really assist us in the warning decision process, help us gauge how bad a storm is. Again, radar may show me the snow at 5, 10, 15,000 feet, but it doesn't show me Is it sticking? What is it sticking to, and how bad the roads are? And this can really provide credibility to our warnings. And anytime I have the opportunity to do an interview with our local media, I really stress that the trained eye of our storm spotters are still our greatest asset. Not going to have a lot of technology on this presentation, but one thing is I want to emphasize some of the limitations that we do have. We have Doppler radar, very, very helpful, but it has some limitations, and that's what this graphic on the right shows. You've got the radar itself, and it sends out a beam of radiation at 0.5 elevation, and you can tilt the radar up and then back down, but never lower than 0.5. So it's always at an angle up into the sky. And because the Earth is curved, as that beam gets farther and farther away from the radar, it gets higher up. So in this example, we've got snow clouds. The snow clouds that are very close to the radar can see the very bottom of them, and it can scan up. So we have a good picture of what's happening. Now, let's say these snow clouds are a little bit farther away. This storm over here, the very lowest angle on the radar may only see the middle or top of the clouds. We call this overshooting the storm itself. And we may not have the full picture of what's going on. So the bottom line is we need your reports. Despite our technology, there are some gaps in them. The other gap is we just don't have a lot of people measuring snow. This image is showing all the airports across our area. Those symbols or the letters, they stand for airport codes. So PGV is Greenville, ISO is Kinston, and so on. And that lighter orange shade, that's roughly our forecast area. So we have a lot of airports. Give us minute data on temperature, wind speed, dew point, humidity, barometric pressure, a lot of good stuff. But most of them do not give us snowfall reports. In fact, only New Bern and Hatteras do we have people measuring the snow at the airport. So very limited coverage with that. And then we pulled up this map. These are our spotters just in the last year or two, so not the total list. And we have a lot of them, and we're thankful, but we can always use more, especially in those rural areas. Notice it's very city-centric. Up toward Greenville, we have an area of spotters, Morehead City and Jacksonville. So if you're watching and you're living in between those cities, we need your reports, and hopefully that map emphasizes it. So that's a little about who the Weather Service is. Protect life and property. We need spotter reports. Despite our technology, we can always fill in the gaps with more reports. Now we're going to change gears and talk about some hazards in our area. It is eastern North Carolina. We're more associated with warmth and humidity, but we can get our share of snow, ice, and wind. We're going to talk a little bit about what makes a winter storm. If you're talking about a winter storm, snow or ice, you got to have cold air. It can't be 50 and have ice. You need moisture, whether that's cloud drops to make a cloud or then eventually precipitation. And you need lift, and lift is rising air in the atmosphere. That's important. As the air rises, it cools and condenses and forms clouds and eventually precipitation. Lift is really the acting agent to get everything going. We'll start off with the thing that we are usually lacking, and that's cold air. We usually look to our friends up toward Canada for a source of cold air. The reason for that, winds flow clockwise around an area of high pressure. So as high pressure builds south out of Canada, we typically have a northwest or northeast wind, and that really drags that cold air down into our area. So this is what we're usually lacking. We usually have precipitation in the wintertime, but we just are not cold enough. And I'll talk more about that, especially when we focus on storm track. The thing that we usually do have is moisture. We have the Gulf of Mexico, Atlantic Ocean nearby, so we have lots of sources for moisture, and then we've got the closer bodies of water like the sounds that are near us. So moisture, that's usually something that we are not lacking. Last thing we need that we do get in the wintertime, but it has to come at the right time, is a source of lift. And if you've watched the Weather Channel or your local favorite meteorologist, there's a reason why he or she talks about warm fronts and cold fronts and low pressure systems, because those are sources of lift. A low pressure system causes the air to naturally rise in it, so that's going to cause more clouds and precipitation. A couple other graphics. The warm front, warm air is lighter, so as it comes in, it rides up over the cold air at the surface. That's an area of lift. A cold front, behind it is the air is very cold and dense, and it pushes its way in and forces the warm air and displaces it upward. That's another type of lift. Temperature differences over lake effect. We don't get that here in eastern North Carolina per se, but if you have friends over toward Asheville, Hickory, the western part of the state, certainly Mount Mitchell, you get a northwest flow, you can actually get lake effect snow showers off of Michigan, even that far downwind, because of that extra lift over the mountains. Not unheard of to have some bay or sound effect snow down here, but usually just doesn't get quite cold enough as frequently. If you're a snow lover, a nor'easter or a storm track up and along the coast, that's what you want if you want snow. And these storms were caused or named those by mariners before we had fancy equipment. They often noticed that the winds would back into the northeast ahead of approaching storm. And with a nor'easter or any coastal system, it's all about the storm track. And what I mean by that is typically with a storm track up the coast or anywhere really, to the left of the storm track, your air is colder. So that's where you're going to have precipitation that has a chance to be snow or ice. And to the right of your storm track, the air is warmer, and that's where it's primarily rain. And the reason for that is winds flow counterclockwise around an area of low pressure. So you're more likely to have southerly or warm winds to the right of the center of the track. And we'll emphasize this more with some past storms. I love pictures. I love to show you what has happened in the past to really illustrate our points. So January 22nd, 2011, last pretty good storm we had in our area. Here's our high pressure that has built south out of Canada. Remember, I mentioned that's important. A north or northeast wind will move that cold air into place. The other important thing is storm track. I was a kid growing up in Maryland, and whether I lived in Maryland or upstate New York, it's all about the storm track. You want the storm to your east. So with this storm, we had a storm that developed off the Florida Peninsula and moved to the northeast. But notice it's not hugging the coast or it's not to our west. If that happens, we're getting plain rain in our area. We need a storm track that is out to sea, close enough to our area to provide precipitation, but far enough away that the cold air can become established. Now, the counterclockwise winds around the low pressure will bring in warm air and moisture. And again, where the two clash, where you have enough cold air and moisture, you will get snowfall. So with that particular storm, again, the storm track was out to sea, so we were plenty cold enough, but we were just on the outer edge of the precipitation shield. So New Bern, north and west, you didn't see anything. Greenville, you're saying what storm? But along the coast, we had 2 to as much as almost 8 inches of snow, especially across Carteret County. So a decent snowfall confined to the coastal sections only. Another thing we can get after these storms is colder air. As that storm lifts up into the ocean, on the backside, very, very cold air can move in. And snow is a great producer of some cold temperatures in terms of that. So that's another threat we have. Want to change gears and go back in time a little bit more. January 23rd, 2003, this storm was a little closer to the coast, so you folks up in Greenville and New Bern had 3 to 5 inches of snow, but 8 to 12 inches along the outer banks. And because of our proximity to the water, not a lot of friction to slow down the wind, it can be quite windy around here. We had 3 to 4 foot drifts with that storm. And I mentioned the cold air. Snow is a great insulator in terms of keeping the warm air not coming out of the ground. And what I mean by that is with a fresh snowpack, you can be 5, 10, 15 degrees colder at night than you otherwise would be with a bare ground. And this particular, the morning after the 03 storm, we had wind chill values below 0. So that's another thing we can get if we do see snow in eastern North Carolina. Do you remember leading up to Christmas in 1989? If you've been here for some time, you do. The bullseye of snow, southeast North Carolina, near Wilmington up through Jacksonville, Carteret County, 15 to 20 inches of snow. That would be a respectable snow anywhere in the northeast part of the country. So especially down in our neck of the woods, a very impressive storm. These are some neat pictures. Carteret County, folks digging out. Bogue is across the western part of the county over toward Cape Carteret. And very, very impressive snows, again, anywhere across the northeast, but especially for eastern North Carolina, where we're just not that used to it. The one that is truly the yardstick or the measuring stick for our area is March 1980. Classes up in ECU were canceled with this. A foot to 18 inches of snow inland, so everybody got into this one. But notice that bullseye, 20 to 30 inches of snow across Carteret County, especially the western part toward Cape Carteret, and then over toward Jacksonville with more than 20 inches of snowfall. Very, very impressive storm. One of our forecasters was a kid that has grown up in this area and lived in Beaufort, and he took this picture as a kid growing up. Certainly an impressive event, no doubt. So a nor'easter or a coastal storm is what we want. Unfortunately, if you're a snow lover, usually they're too close to the coast and we are rain, and they might be winter weather farther inland. So if you want a snowstorm, you want to track up the coast, but watch it, and you want it just far enough out to sea to allow the cold air to come down. An Alberta Clipper is another storm that we can get. It's called an Alberta Clipper because it typically develops in southwest Canada near the province of Alberta. Called a clipper because it moves fast. And because it moves fast, unlike a nor'easter or a coastal storm that has time for moisture off the Gulf of Mexico or time for moisture off the Atlantic Ocean, the clipper is moving so fast it doesn't have time for this. So with a clipper, with the storm track just north of it, you could get 2, 3, maybe 4 or 5 inches of snow. Typically, you're not going to see a big one, certainly not a 1 or 2 foot storm from a clipper. And with clippers, most of them are to our north across the Ohio Valley and the Mid-Atlantic, so we don't see them. If we were to see something, we need to dive south along the North Carolina, South Carolina border, then we would be in business for some snowfall. It can happen, but not quite as common or not quite as good for us, certainly in terms of a huge snowfall in our area. I love this graphic. This is a graphic showing the different precipitation types. This is from the COMET program. We'll work our way from the left to the right. Far left, temperatures below or near or below freezing from the cloud down to the ground. It's snow. And I mentioned earlier, warm air is lighter. As warm air tries to come in, the cold air is very, very dense and stubborn. It's not leaving the ground until it has to. So the warm air actually comes in higher up first. And so this is where you get your transition to sleet, freezing rain, and rain. So that pink or reddish shading is a layer of above freezing air. So in the case of sleet, the snowflake falls into that, melts into a raindrop, but then below that is a thick enough layer of cold air that it refreezes into an ice pellet. So that is what sleet is. Now if that warm layer is deeper, when the snowflake melts into a raindrop, it stays a raindrop all the way until it hits the ground, and then it freezes on contact or the surface. That could be your car, that could be your sidewalk, tree branches. This is freezing rain, the worst thing to drive in. And then if that layer is completely above freezing, on the far right, that would be rain. A lot of times we get the question, how is sleet different from hail? Sleet's a one-way trip. Again, the snowflake melts, it's a raindrop, it freezes into an ice pellet, and it hits the ground. A hail is many, many, many trips, and it occurs in the summer. With hail, you have possibly a snowflake at the start, but as it falls, it falls into a warmer layer and turns into a raindrop. But because of very strong winds and a thunderstorm called an updraft, it gets pushed back up into the sky. If the updraft is 30, 40, 50 miles per hour, that raindrop goes back up into the sky high enough that it freezes, and because of gravity, it falls back down. And it may only take 1 or 2 trips because the winds are not very strong, and it falls as a pea-sized hailstone. Let's say we have very strong updrafts, 80, 90, 100 miles per hour. Again, that's rising air in a thunderstorm. That water droplet falls, gets sucked back up into the cloud, freezes because of gravity, comes back down, back up into the cloud over and over again. So this is a cycle, and it will continue to grow, perhaps as large as a golf ball size hailstone. And this is why if you have a large hailstone and you cut it in half, you may see what looks like tree rings or layers because it's a multiple trip. So hail associated with a thunderstorm, multiple trips. Sleet is a wintertime phenomenon, and it's a one trip down to the surface. Talk a little bit about ice storms. We mentioned freezing rain. Luckily, we don't get a lot of ice storms, but they can have huge consequences because the ice accumulates on everything, and everything could be trees and power lines. losing communication and power. And a lot of us are very blessed that we have air conditioning in the summer, and it would be an inconvenience to not have that air, but more than likely we would be okay. Different story if it's 20, 25 degrees out at night and we don't have heat for many days on end. And that's why ice storms are so serious. The ice could be gone, but it takes a while to clean up from the downed trees and power lines. So that's why ice storms are certainly a concern with us as the Weather Service. So we went over the hazards in our area, talked about who we are. We're going to do a couple more slides on how we issue products, and then we'll focus on how to measure snow and ice. This graphic shows our tiered approach of products. On the far left is time of the event and certainty. So the upper left corner, we're way out and we're very uncertain. That's where we would issue an outlook. Hazardous weather outlook, hey, we might have a storm 5 days from now. Too little confidence to say anything about amounts. As we get closer, become more certain, closer to the event, we may issue a watch. This is where confidence increases to at least 50% or greater. And as we continue to get closer and we become more certain, we issue a warning or advisory. So a hazardous weather outlook, confidence is low, and I try to highlight in yellow the most important points. A watch is a 50% chance, so our confidence is only medium. We certainly want you to prepare, but it doesn't mean it's a sure bet or it's going to happen. It just means a medium chance. An example would be a winter storm watch. And then when we get really close, I should back up one. A watch is usually a day to maybe 3 at most in advance. A warning or advisory is usually 12 to 36 hours. And a warning and advisory mean the same confidence. We are 80% confidence. This is imminent. It's going to happen. We're confident. The difference is the impact. A warning is life-threatening. 5, 6, 7, 8 inches. You're going to get, could be in big trouble if you go out on the roads. It's life-threatening. An advisory, maybe a dusting of snow, a 1/4 inch, may still get out of school, but it's more of a nuisance than anything. So a warning and advisory, same confidence. A warning is life-threatening. An advisory is nuisance. So that's the difference between those two. You might say, Eric, how can I get this information? Our website's a great place, weather.gov, or I encourage you to go to mobile.weather.gov. We still do not have an official Weather Service app, but if you go to mobile.weather.gov, enter your city or zip code, and once you get that up, if you have an iDevice, at the very bottom there's a rectangle with an arrow. If you click on that and scroll over, and there's an option for saving it as a bookmark or add to home screen. I want you to add it to your home screen and then say OK, and then you'll see a Weather Service icon on your mobile device, and you click on that and it'll act very similar to an app. It'll redirect you to the page and you'll get a forecast. If you're an Android user, you're not out of luck. Same thing, go to mobile.weather.gov, pull it up in your browser of choice, get the city that you want for the forecast for, then stop. And then for you, at the top of your device, there's 3 little dots. Click on that, and again, you might have to move around a little bit, but find where it says Save to Home Screen. Click on that, say yes or add, and then again, an icon of the Weather Service will appear on your home screen, and that will be very, very similar to an app. Want to encourage you, you're watching this on YouTube. We're also on Facebook and Twitter, NWS Morehead City. And as always, a no-weather radio is important, especially severe weather, things that you want to hear in the middle of the night, tornado warning or severe thunderstorm warning. So you've made it through about 2/3 of the class. I call that the homework section. We kind of had to get all of that out of the way. Now is my favorite part, the last third. We're going to talk about how to measure snow and ice and other observations you can make. Measuring snow tends to be a little bit more difficult than rainfall. What I mean by that is you can get a digital rain gauge and read it from the comfort of your home. With snow, you've got to put the jacket on, got to put the boots on, and go out, take measurements. So it's a little bit harder. And the point of this course is to give information to the Weather Service, but this is extremely useful to our broadcast partners, emergency management, public works. So it's not just us that rely on this information. First thing you need to do is select a good location. That starts now. Where's the best part in your, part of your yard that would be good for measuring? It should be open ground, and what I mean by that is you don't want to be by a building, don't want to be by a tree, but also you want to be protected so it's not an area that would drift. And not all sites are going to be perfect. Perhaps you're in a forest location, a rural area that drifts, or even an urban area with tall buildings. It's not going to be perfect. You want to get as close to it as possible. So this would be ideal. You've got trees that slow down the wind, but you're still open enough that you're not measuring right by it. So that would be ideal. And again, now's the time to kind of think of, hey, where's the best spot in my yard? This is an example of measuring snow under a tree. You might say, well, that's not too bad. There's snow there and not a huge difference. In fact, this gentleman measured 3 inches of snow. So there's snow there, but watch what happens as he walks into the middle of the yard. This is your typical suburban lot. You've got a fence and some trees, but he's in the middle part of the yard and he measures 6.5, a tremendous difference. So the point of emphasis with that is do not measure under a tree. What can you use to measure? A ruler, measuring tape, if we're real lucky and get a big storm, a yardstick. So any of those would be perfectly fine. And we want you to measure to the nearest 1/10 of an inch. I know a lot of rulers don't have that. We just want precision. And what I mean by that is snow doesn't always fall in 1 inch, 2 inch, 3 inch. It could be 3 3/4, 1 1/4. Again, we're just asking for some precision. And we do want you to take an average. What I mean by that is when the plow comes by and there's a big drift of snow at the end of your driveway, don't measure that. If you see obvious drifting, don't measure in those areas. Just put your ruler in a couple level spots and take an average. This is a little exaggeration. You don't have to do long division, but again, just take a couple measurements to get an average. What should you measure on? Measuring on the grass is fine. It might be a slightly higher amount because you're going down into the grass blades. A deck, a little bit better because it's a hard surface, but sometimes it might be too close to a house. A snowboard would be the best. We don't get a ton of snow here, but they are pretty easy to measure. What a snowboard is a piece of plywood, 2 feet by 2 feet, and paint it white. And why it's good is it's an absolute zero. If I have my ruler and I put it down into the ground, I may be going into the ground or into the grass blades, but with a board, I'm actually hitting something to have my zero. And you can place it where the best spot is. So a snowboard would be best, and if you're going to use one, since it's painted white, put out some stakes so you know where it is, because after a couple inches of snow, we will not be seeing that white board in the snow. So how often should you measure? Most important is at the end of the event. We just want to know how much snow fell where you lived. If you want to measure more often, especially if it's a big event and you're stuck at home anyway, call us halfway through. Hey, Eric, I want to let you know we're up to 6.5 inches here in Greenville. I'll call you later today when the snow is done. That would be an example. So at least at the end of the event, if you want to measure halfway through and do it twice, that's fine as well. This is an example to emphasize measuring as close to the end of the event as possible. Snow starts on Monday morning at 9 o'clock. It stops by 1 o'clock and we have 2.4 inches of snow. That's when you want to measure as close to 1 o'clock in this example as possible. Sun could come out, temperatures could warm up, and as that happens, the snow settles, melts, and in our case, it may completely go away. In this example, by the next morning, we have 1.2 inches of snow. So the bottom line is, once it stops, we want you to measure as soon as possible before things change. So quick summary, and then we'll get you out of here. A nice level place, no drifting. You want to slide the stick into the grass or to your snowboard. Take an average, and again, we're most concerned with the newly fallen snow at the end of the event to the nearest 1/10 of an inch. When should you call? I moved down from upstate New York. We had to set a limit to that because we got quite a bit of snow. Since snow doesn't occur as often here in eastern North Carolina, anytime it happens, we want to hear from you. If you take a measurement, again, by the end of the event, for sure. But just letting us know it's snowing, that's important. Letting us know that you have ice, that's important. Not as concerned about the thickness. We want you to be safe. If you do want to go out there and measure it, look for like a tree or a tree branch and you can measure the thickness. But it's more important for us to know what it's sticking to. Only the cars, only the trees, or my sidewalk is a sheet of ice. We need to know about that. So if you get any amount of ice, we certainly want to know about that. First way you can report to us, we're going to go over a bunch of ways, but we put this up front and center. This is our preferred way. Rings directly into the office 24/7. We can ask you questions. It's the best way we would like you to report. We'd like for you to say who you are. I'm a trained spotter, where you live, what your observation is, and the time. So again, it's 800-889-6889, 800-889-6889, and call us with that information. You can also send us an email. Still want you to say who you are, what you saw, where, and the time. But the email is a good way to send pictures to us. So maybe you call us and let us know that you have a foot of snow. Encourage you to send us a picture. We'll certainly share that with our friends on social media. What else you can report? This is down the road. We have a basic class in the spring that focuses on tornadoes and hail. Anytime you have that, we want to hear from you. Flooding. So again, the toll-free number is what we want you to use because it's urgent and we get that information right away. There are some other ways you can report. One is social media, Twitter or Facebook. If you just search NWS Morehead City, you can certainly submit pictures that way. That's not a bad way to do it. In fact, on Twitter, I mentioned mobile.weather.gov. If you scroll down on that, there's tweet a weather report, and I did an example and send a tweet to ourselves. It'll put in hashtag NWSMHX, and we'll see that. You can tell us what's going on. So those are other ways to report. I don't want you to do all of them, but just want to let you know what's out there. Speaking about what is out there, if you haven't done Coco Raws yet and you're a younger person interested in weather, retiree measuring the weather, if you're already measuring the weather, I want you to consider this. This is a program where you log on every day between 7 and 9 in the morning and you report precipitation. Most of the time it's going to be 0, but if you have rain or snow, you log into the website and report that. We get this information, but it's also very useful for climatology and to look back. There's excellent training. You can send me an email if you have questions, but if you go to the website, cocoroz.org, the upper right, there will be some very, very good training. You'll probably recognize some of the slides on snow measurement. So to sum things up, we would prefer you report the 800 number. Our email and social media are ways you can send pictures into us. Mention Coco Raws, and really want to thank our friends in the amateur radio community. If you have your ham license, if we have a major snow or ice storm, often we have hams in the office to collect reports that way. So we really try to keep the variety high so that we can get reports into the office. Looking forward down the road, we do offer a lot of classes here. We're trying to increase the variety. We mentioned that this is the basic winter class. We have a basic spring class which goes over tornadoes and hail. We're looking to introduce a flood and tropical class that would cover some of the historic tropical systems we've had, such as Matthew and also Floyd, while covering flash flooding. And then we've done an advanced class in the past looking to bring that back. And the whole idea is to increase the variety because we know you can't attend every class. So we're putting them online, right here at YouTube. We're doing webinars online, and we're trying to increase the amount of classes so that you can get to it. Because in reality, our traditional SKYWARN, tornadoes, and hail, you may never see that, but you probably will be able to measure rain and you'll be able to measure snow. And so we want you to get used to the habit of reporting to us so it's second nature. If you like this, check out our website. It's weather.gov/MHX. At the top is our SKYWARN listing. In general terms, we teach our winter classes, roughly November, December of each year. Our spring classes are roughly late March through early May. Flood tropical could be any time of the year, but the focus with that would probably be spring and summer, and same with the advanced. So it'll vary year to year, but check out our website for more information. And if you've got any questions at all, shoot me an email, erichayden@noaa.gov. Really trying something new here. We appreciate any feedback, any comments on this YouTube video. And if you want to become a spotter for us, please send me an email and I'll make sure you get the link to sign up to become a spotter. It's a Google form that you'll fill out and that will submit your information. So again, send me an email. Really appreciate you joining us, and please give us some feedback on what you think of this YouTube presentation.